we look again at an equation of an ellipse. You can tell that this is an ellipse because the x squared term and the y squared term are both positive, and they have different coefficients. So that when we end up completing the square, if we end up with a positive number in the right-hand side, then we've got an ellipse. If we end up with a negative on the right-hand side, after completing the square, we've got something that's just impossible. We go through the process of completing the square. We've already got all the constant terms on the right side, so we're going to complete the square on this and this. In order to do that, we first factor out the 4 in front of the x squared here, so that we end up with just a 1 in front of x squared. That's going to make completing the square a whole lot easier. And we factor the 9 out here, ending up with just a plain old 1y squared in parentheses. Then we complete the square within the parentheses. We're completing the square on x squared minus 4x. Since we have just a 1 in front of the x squared, we square half the coefficient here. Half of negative 4 is negative 2. We square that, we get 4. So we get x squared minus 4x plus 4 minus 4. If we're going to add 4, we'd better subtract 4. Then we will not have changed anything from up here except just the appearance of the term. We won't have changed the balance of the equation if we just add and subtract the same number. We've essentially added nothing. Then we do the same thing here. Half of 2 is 1, the square is 1, so we add and subtract 1. Then we distribute the 4 and the 9 back through these terms. Well, no, we're going to do that, but we go ahead and factor the x squared minus 4x plus 4 into a perfect square, the y squared plus 2x plus 1 into a perfect square, leaving the negative 4 and the negative 1 here. Then we distribute the 4 and the 9 through the respective terms, and we end up with this. And so far we haven't changed the right-hand side at all. But now we've got a negative 16 and a negative 9 here. And negative 16 and negative 9 is negative 25. When we add 25 to both sides, we end up with 56, not 48. So there's an error here. And you should make note of that error. This should be a 56, not a 48. But let's pretend that the 48 was correct, just as not to get too confused. To get the standard form of the ellipse, we need a 1 over here, so we'd better divide both sides by 48. We end up with x minus 2 squared over 12 plus 9 times y plus 1 squared over 48 equals 1. And then we want to express this in the standard form. It's a little hard to figure out how to focus this. We want an x minus 2 squared over the square of something. Well, that would be then the square of the square root of 12, right? So we'd have x minus 2 squared over the square root of 12 squared, which is what we have here. Now the y plus 1 squared, we got 9/48 of y plus 1 squared. Well, that's the same as y plus 1 squared divided by 48/9. Just take the reciprocal of the 9/48, put it in the denominator here, we get 48/9. If we want that to be the square of a number, it's going to be the square root of 48/9. So that we have y plus 1 squared over the square root of 48/9 squared. And that, of course, equals 1. And we see that A is the square root of 12 and B is the square root of 48/9, which is the square root of 16/3, which is 4 divided by the square root of 3. That's not really very good form. 48 over square root of 48 over 3 might have been better form. And then 4 times the square root of 3 over 3 would have been even better form. So this isn't in real good form here. In any case, this is the correct form for the equation of an ellipse.